the only thing we really need to finish up about our section 12.1 when we talked about right triangle trig, and we certainly learned SOHCAHTOA, which everybody should be super familiar with, okay, is when we're dealing with some of these word problems, making sure we understand all the language and how that's used. And the two biggest things you're going to hear are angle of depression and angle of elevation. And the example I usually give would be the lighthouse here on the shore is looking out at the boat out here in the water. Okay, and he's up at the top of his lighthouse and he sees a boat in distress and he says, "Ooh, I better locate how far away it is." So he sights along this line of sight, okay, and he wants to measure his angle of depression. Now, angles of depression and angles of elevation are both given from the horizontal. So here's a horizontal, okay? So when he's looking at the boat, his angle of depression is from the horizontal to his line of sight, and that would be your theta, or angle of depression. Likewise, if you're a guy sitting in the boat and you're looking up at some light in the sky and you want to know how tall is that lighthouse, the boat has a line of sight to the top of the tower, okay? And when he looks at that, he wants to know what is the angle from his horizontal. Well, his horizontal is this green line here. This is his horizontal. Therefore, his angle is the angle of elevation here. Okay, so you talk about angle of depression, and when you look at it the way I've drawn it, it looks like that angle of depression is outside this right triangle, because of course you're always trying to locate where is your right angle, so I can have a right triangle, so I can use SOHCAHTOA. So that's an important thing, is to locate that right triangle. And it looks like that angle of depression is sort of outside the right triangle, but there's, you know, of course, many ways to get around this. The one that I most often do is to recognize, well, if I have these two parallel lines, the red horizontal up high and the green horizontal down low, they're both horizontal lines, therefore they're both parallel to one another. So what I have is two parallel lines cut by this transversal. The line of sight is the transversal. And those two angles, angle of depression, angle of elevation, would be alternate interior angles, and therefore they are equivalent. Okay, so once you find that angle of depression that's up here, right, it's going to be the same thing as the angle of elevation as measured down low inside the triangle. So those are the same. The other way to get around it is to drop a different vertical from, well, I say drop a vertical, but from the boat to the lighthouse. So you could use that one. That one, you won't see me use it as often, but maybe some of you are already in that habit, and that's fine. Okay, so I just wanted to do one word problem with you in order to demonstrate this. The roller coaster problem. Boy, that's where we need to take our field trip. The hill on the roller coaster has the angle of descent, okay, which is a roller coaster term. We interpret this as an angle of depression of 60 degrees. The vertical drop is 195 feet. Find the length of the hill. Alright, so let me draw, okay, here, let's imagine it's a straight and not a curve descent. Okay, so that's my length of my descent. Let's see, I have a right triangle to draw. So let me put a right angle. Now it tells me the vertical drop is 195. So that would be from here to here. So this right here, the vertical drop, 195. Okay? And then it's going to tell us the angle of descent. So remember, we're going to measure that from the horizontal up here. So this right here is 60 degrees. Okay? And they want us to find the length of the hill. That means they want us to find this length here, the hypotenuse. Okay, so we're trying to find that hypotenuse. So, what am I going to do with the 60? Well, I'm going to move the 60 down here, so it's inside my triangle that I have drawn, or I could redraw the different triangle. And then I'm going to imagine SOHCAHTOA and decide which of the 6, but really which of the 3, SOHCAHTOA, oh boy, which of the 3 is the appropriate one in here. So here's my angle. When I look at 195, that is opposite. Okay? When I look at x, x is hypotenuse. So looking at this, I know I have an angle, I have an opposite, and a hypotenuse. So that's really lending itself to a sine function. So I'm going to use SO of the SOHCAHTOA. So the sine of some angle is equal to the opposite over the hypotenuse. And in my case, I have the sine of 60 degrees is equal to the opposite, 195, over the hypotenuse, x. And of course we need to solve this by rewriting this equation. And that would be x is equal to 195 over sine of 60 degrees. Be very careful that your calculator's in degree mode, but other than that it should be simple to find that answer, and it would be in feet because the 195 had been in feet already. Alright, so hopefully this is a review for you and a reminder of those angle of depression and angle of elevation. We'll try to do some more in class.